Okay. Let us start discussion, a brief discussion about energy. Energy actually energy is stored up work in a system or in a body. Suppose there is a body and this body can perform work somehow. This work, the amount of work is stored up inside this body. So energy is called the stored up work in a system or in a body. Let us consider this is a body of mass m. Now this body can do work if it has a velocity v is the velocity of the body, or due to its position in a space, or due to its configuration. So we can say the energy of a body is stored up work if we define energy in such a way that energy is measured by total quantity of work that a body or a system or bodies can do. Energy is measured by the energy is measured by the total quantity of work by total amount of work that a body or a system of bodies can perform. For simplicity, I consider a single body of mass m and the body or the mass has a velocity v. Now, this energy is, in this case, in an entire discussion, this energy is mechanical energy. Mechanical energy you can define also mechanical energy in such a way. The mechanical energy of a body is the capacity of that body of doing work due to its motion or velocity or position or configuration. Now, we have already discussed that this particular body has motion and its velocity is v, and we again say that the height of the body from reference frame, suppose this is ground level, and the height of this body from ground level is equal to h, small h. H is equal to height of the body from ground level, and the ground level, this ground level is the reference plane. With respect to this plane, the height is measured, and this point, for simplicity, this point is the midpoint of the body. Now, mechanical energy can be divided into two types. One is kinetic energy, another is potential energy. The body can perform work due to its velocity and due to its position. When due to velocity, that type of energy is known as kinetic energy, and due to position, this body can perform some work, and that energy is known as potential energy. Now we calculate what is the kinetic energy. Kinetic energy, it is defined as Ke or Ek. K stands for kinetic, E stands for energy, kinetic energy. So the body has velocity v, it has mass m, and due to its velocity v and mass m, it can perform some amount of work. And that work, that amount of work is the energy possessed by the body due to its velocity. Now we shall calculate what is the kinetic energy of the body due to its velocity v and due to its mass m. We know this body possesses some energy, that is kinetic energy due to velocity. So when velocity is zero, the kinetic energy of the body will be zero. Now, the amount of work done by the body for a state of the body where the velocity of the body is zero, that amount of work is amount of kinetic energy. The amount of work done against this body to make it motionless, the amount of work done to make it motionless, that is the energy stored in the body. Now if we want to make this body motionless, then we have to apply a force against this body, and this force will produce a retardation. We know from Newton's law, if the mass of the body is m and applied force is equal to F, the retardation of the body F is equal to force by mass. This is the retardation of the body. And under action of this force, or due to retardation of this body, retarded motion of the body, the velocity of the body becomes 0. So, before its motion, state of motion becomes, velocity becomes 0, it will traverse some distance, and throughout this distance, an opposing force or retardation producing force F is acting on this body, and the initial velocity of the body is equal to V, final velocity is equal to 0, retardation is equal to F, distance travelled by the body is equal to S. So from the equation of motion of the body, we can say the final velocity square is equal to initial velocity square minus 2 into retardation into S. This is the equation of motion applicable under such circumstances. Initial velocity is equal to V, final velocity is equal to 0, distance travelled by the body before it becomes motionless is equal to S, this distance is S, and retardation produced by the opposing force F is equal to F. F is equal to F by M, and in this condition the equation becomes 0 square is equal to V square minus 2Fs. Actually, this formula is equal to V square is equal to U square minus 2Fs. But this form has been reduced here. V becomes 0, U is equal to V and 2Fs. So from this equation we get F is equal to V square by 2S. F is equal to V square by 2S. Now, the work done to make this body motionless is equal to the work done to make this body motionless. We know work is equal to W is equal to force into distance is equal to, force is equal to M into F, and distance is equal to, in this case distance is equal to S is equal to M. In place of F we can say V square by 2S, V square by 2S, and S again, S is cancelled, is equal to mv square by 2. So the work done to stop this body, to make it motionless, is equal to mv square by 2. So this body must have energy mv square by 2 when work is not done. That is why we can say the kinetic energy possessed by the body, Ke or Ek is equal to half mv square. Energy is stored up work. So the unit of energy and unit of work are same. Unit of work. So in SI unit, the body has energy half mv square. Half mv square. Ek is equal to. An important relation, Ek is equal to half mv square is equal to half m square v square divided by m. M square by m is equal to m. Again, mv is equal to momentum according to our used convention notation. Half in place of m square v square, we can say p square by m, where p is equal to mv is equal to momentum of the body. Hence, Ek is equal to p square by 2m or 2m Ek is equal to p square or p is equal to root over 2m Ek. This relation is an important relation. That is the relation between momentum and kinetic energy. So this is the primary discussion about momentum and kinetic energy, an expression for kinetic energy also. So there may be so many problems. Suppose a body has momentum, numerical problems like this. A body having momentum P and kinetic energy Ek. Momentum P and kinetic energy Ek. We can relate P is equal to 2m Ek. This relation and Ek is equal to half mv square. This relation, these two relations are useful for solving numerical problems, and there are so many numerical problems in your textbook, like I am giving a like this, a simple problem. So which one of the two bodies, one heavy and one comparatively light? I am writing the problem. So which one of the two bodies. So which one of the two bodies one heavy and one heavy and other lighter. Having equal momentum. Equal momentum has greater kinetic energy. So, which one of the two bodies, one heavy and other lighter, having equal momentum has greater kinetic energy? I am explaining the problem. Suppose there are two bodies, one heavy and other is lighter. This is heavy body, lighter. The two bodies have same momentum. Suppose this body has the velocity v, capital N, capital V, and this body has velocities v. Then momentum of first body, this is number one body, and this is number two body. So which one of two bodies, one heavy and other lighter, having equal momentum has greater kinetic energy? Now we have to determine which has the greater kinetic energy. It is heavier body, it is lighter body. Now the condition is equal momentum. That means we can say mv is equal to mv. This is the condition. Now we can say the heavier body has kinetic energy capital EK, and lighter body has kinetic energy small ek. Now Ek is equal to capital P square by 2m. And for this, small p square by 2m. Remember, capital P is equal to mv and small p is equal to mv. Capital P is equal to mv and this is small p. Now, Ek by small ek, the kinetic energy of the heavier body divided by the kinetic energy of the lighter body is equal to p square by 2m divided by p square by 2m. Actually 2 pp, this p and this p, these are equal to each other. So these are cancelled and this is equal to small m by capital M. Small m by capital M, this is small, this is capital. So this is less than 1. That means Ek by Ek is less than 1 because m by m is less than 1. This is small, this is large. Or from this relation, Ek is less than small ek. Capital Ek is less than small ek. So we can say this is the kinetic energy of lighter body. This is the kinetic energy of the heavier body. So we can say the lighter body has more kinetic energy. You can infer the lighter body has more kinetic energy. Now, to solve this problem, we have taken another relation. Ek is equal to p square by 2m from this. Ek is equal to p square by 2m. Now I am giving a problem to solve. So which one of the two bodies, one heavy and another lighter, having equal kinetic energy, has greater momentum? You have to solve this problem. Just I have changed slightly. In place of momentum, I have given kinetic energy. In place of kinetic energy, I have written momentum. Now solve yourself, and then we shall go to the next topic, that is work energy theorem. Next topic would be discussed work energy theorem. Work energy theorem. Thank you.